So my goal is I want you to know that I do understand that word problems can be tough. Um, I can tell you on the test, there's going to be 3 word problems. 2 of them will be on the Schoology, and 1 of them will be on the pencil paper part. And the test is done. I think we have 6 problems on Schoology, and then there's 9 problems on the pencil. There's the front and back. So I think it's a good test. I think it's a fair test. I think it's, and there are 3 of those. Three of those are word problems. So I do understand that word problems can be tough. A lot of times we will design these word problems to come out where you can kind of use a little bit of logical thinking to get the answer, which is great. But sometimes on a test, when I get it back and I get it just nothing, and it's like, if it was a nickel and dime problem, sometimes you can sit there and just try and finagle how you can make the nickels and dimes work to get, just try something, but blank gets you nothing. So, we're gonna work through each of these problems, and I want to work through slow, and I want to work through, and you know me, I'm gonna be somewhat sarcastic, and we'll have some fun with it. But it is important that you kind of use this as your notes as well. Okay, I don't have a note sheet today because we're not really doing anything different. Okay, so problem number 1 on page 162 says a family purchased 13 gallons of drinks for a camping trip. Some of the gallons were sports drinks that cost $4 per gallon, and other gallons were iced tea that cost $3 per gallon. If the cost of 13 gallons was $47, oh wait, there's somebody who's using a phone, but he's brand new, so he doesn't know that I take phones away from kids. If the total cost of 13 gallons was $47, how many gallons of sports drink and how many gallons of iced tea were purchased? Okay, so everyone comprehends that we have some sort of cooler. This is a cooler for you. A little spigot on there. And in these coolers are either iced tea, and let's just pretend I'm a really good art person. I know I'm not. So one I have iced tea, and then one I have some sort of sports drink. Gatorade or something. I don't know. So this is basically our situation. You get this okay? Now, I know it would be weird if we brought a big old tub like that. I don't know. We have a scenario that's taking place. So between these 2 buckets, there's a total of 13 total gallons. So if I add up the total gallons, there's 13 gallons between these 2. Does that make sense still so far? And yes, I'm using a picture because we're depicting the situation, which sometimes it's easier to understand. So how much does the sports drink cost per gallon? $4. Yeah. So this one costs $4 per gallon. And how much did the iced tea drink cost per gallon? Yeah. $3 per gallon. And how much did we spend total on our drinks? $47. So if I were to add up my monetary amount, I spent a total of $47 on my sports drinks. Okay? So again, we're looking at kind of a visual representation. So there's 2 equations that can be generated out of this. And just for a sense of math purposes, let's call the sports drink X and we'll call the iced tea Y. Is that okay? So if I take my top equation, it's going to be X plus Y is equal to 13. And if I take my bottom equation, it's $4 for X and it's $3 for Y. and we had to spend $47. Now, I don't necessarily have to worry about the decimal on this case. So those two red equations basically came from the story from above. Is there any part of that that's misleading?
Which number are you doing?
Problem number 1.
First one is about 1.
What? I'm on page 162.
I do 164.
Oh!
That's what I'm saying. Like, what? You
Oh.
did not go over none of this.
I'll wait for you to get it out. As soon as you see number 1 on page 162, you're like, I'm with you. I'm sorry about that. So, everyone else on the right page? This makes sense so far. It's just that we're trying to do a visual representation. We're trying to create two linear equations. We're using x and y as my two different types of drink. Yeah.
Okay, so I know you're gonna go over this, but like I'm confused on how you like get x on one side and y on the other side, but you still divide both. Right? Is that what you do that?
So you're good up to this point. It's just further on
Yeah.
the problem.
That's what I thought.
All right. All right. So, but you're good up to this.
Yeah.
Okay. So let's see if we can backfill to catch you up on that. All right. So everyone feel pretty comfortable about how each of these equations came about?
Yeah.
Okay. These both appear to be set up to use elimination. So we need to get rid of one of the letters. So we need to pick at this point, should we get rid of our x or should we get rid of our y? You want to go get rid of the y? Okay. So, because if I add the equations together right now, I get 5x plus 4y equals 60, and that doesn't do anything for me. But if I decide to get rid of the y, I'm going to multiply the whole top equation by negative 3. So, just move this over like this. So, negative 3x minus 3y equals negative 39. And then, did I do anything to the second equation? No, so let's move that over as well. So everyone feel comfortable with what I did? So the top equation, I distributed negative 3. And we did that because we wanted to get rid of y. If we wanted to get rid of x, we would have multiplied the whole top one by negative 4 because we want opposite values when we add them together. Okay? Does everyone feel comfortable if I add the two blue equations together, the y goes away? Make sense? So negative 3x added to x, or to 4x is 1x, or just x. These cancel, and that's equal to 47 minus 39? 8. So what does 8 mean in the context of our problem? Yeah, I have 8 gallons of the sports drink. Okay? So I have 8 gallons of this so far. Hey, how many total gallons did I have?
13.
13. 8 of those gallons account for our sports drink, so the iced tea has to be what? 5.
I get it now.
Does that seem to be an okay thing? Was that an okay pace how I walked through it?
Yeah.
Some of you are like, dude, you're going too slow, man. We're working backwards. But I think some of you would be like, man, I feel okay about it. Okay. May I move to the next slide? Do you have the appropriate notes off of this? Cool. All right, so problem number 2, I think it has to do with somebody reading a book, I believe, I think.
Yeah.
It says, Rachel reads twice as many books in July as she did in June. Okay. She read a total of 24 books during these 2 months. How many books did she read each month? Okay. So between the 2 months, she read 24 books. So let's draw a picture of a book. There's one book. That's a what? No. All right. Here, we'll make it more friendly. Let's do this.
Hey, mister, I got the answer.
Okay. feel it is?
8 books in the first month and then 16 in the other month.
That could be.
Why is there cards? Cards? Yeah, we like cards.
Wow, that clearly didn't do what we wanted.
Where? On that board, on the whiteboard? Yeah, there's just like 3 cards. Oh,
Here?
cards! I thought you said cards. I said, where are the cards? I'm over like looking for cards.
All right.
There we go. I don't know why you did that, but it's okay.
Well, it gives us a visual representation of the problem.
I didn't. I said they were good books. I said they looked good.
All right. So now we have a books. That's what they mean. All right. So some of you might have been finding out, but we have June and we have July. So we'll call June X. We'll call July Y. Is that okay? So between June and July, this person read how many books? How many? 24. So, is it possible they read 12 books in 12 books?
Yeah.
As far as this goes, it could be. But then they give us another hint. It says Rachel read twice as many books in July as she did in June. So July, the month of July, is equal to, July we called Y, right? Read twice as many books as June had. Does that make sense how I have that set up? So I have one equation of x plus y equals 24. And then we know that they told us that in July, a person read twice as many books as June's reading. So if I think about this, I might think about using substitution on this problem. So I know that y is equal to 2x. So if I take this value and plug it in right there, I get x plus 2x equals 24. Yes? X plus 2x is 3x. Divide each side by 3, so x is equal to 8. So x was what month?
June.
X was June. July was Y. So there was 8 books read in June. And then in July, there was twice as many read. So I had 16. So 8 plus 16 is 24. I think that's, I said you said that, right? Cool. I like my visual representation of books.
I loved your first one. I thought your first one was better. I don't know why you replaced it.
I don't know, because I thought somebody would think it's like birds flying. Or, I don't know.
Well, birds flying is just like that. If you add like more lines, it's fine.
I
It looks
know.
like a bird.
I understand. All right. Next slide. Can I move on?
Right? I don't know. I'm probably not going.
What? Can't you explain? Give me a break. Give me a break.
What?
Let's see. Save picture as. Save picture as.
You really just said that. Because now What? That's so weird. But it's okay. I didn't like my stick figure. What are you doing?
Oh, someone's bigger than somebody else.
Uh-oh. Wow.
It's really big.
Oh my god.
That's really making my learning great.
All right.
He's still smaller. Other dude's head is bigger.
Genetics. All right. So we're going to call this one Sam, and we're going to call this one Devin. Now, I didn't pick the pictures for any other reasons than I thought, okay, we have a visual representation of a couple of people who are going to work, supposedly. Says Sam worked a total of 4 hours this past weekend. Okay? Devin worked a total of 6 hours. All right, so let me do this. We're going to call Sam X, and we're going to call Devin Y. Is that okay? How many hours did Sam work this weekend?
4.
4 hours. Okay. How many hours did Devin work?
6.
6. All right. Bless you. So Sam worked a total of 4 hours this past weekend. Devin worked 6 hours. Sam earns $8 less per hour than twice the amount Devin earns per hour. Whoa. What? All right. Okay. Let's see. Hang on. Sam earns $8 less. So Sam earns $8 less. I'm going to subtract 8 from something. Then twice the amount Devin earns. Okay? We called Sam X, we called Devin Y. Sam earns $8 less than twice what Devin makes. Devin is Y, that's why I have 2Y. So Y is going to represent the hours, or the amount of pay. The total money the individuals earned this weekend, $220. What do you think? So, I know that if I were to take these two values and add them together, that's going to say, if Sam and Devin came and they threw their money down and then someone counted it, they'd say, okay, between the two of you, you earned $220. And then somebody pipes up and says, hey, Sam makes $8 less than twice the amount of Devin. So if Devin made $5, you plug a 5 in for the Y, and that would mean Sam would make $2. But I don't know what the amount is. Okay, so I have x plus y equals 200, and then I have another equation which is 2y minus 8 is equal to x. So how is these two equations kind of set up for us? Elimination, substitution. What do you think? Elimination might make it tougher. Do I have a letter equal something on one of my equations?
Yes, you could use substitution.
Yeah, I know that x is equal to 2y minus 8. So I could take this right here, and I could plug it in right here. Okay? So let's do that. So I'm going to use this equation. Let's bring it over here. For the x, I'm going to put 2y minus 8 in. And then I'm going to add this y plus equals 220. Oh, wait, 220. Can't write. So 2y and y, that's 3y. Minus 8 equals 220. Do I add 8? Add 8, okay. So that's 228. And then I divide each side by 3. I think I can do this. I think it works out. Let's see. 3 goes into 22 7 times with 1 left over. And then 3 goes into 18 6. Okay, so Devin earned 76 of the dollars. And then Sam would have, okay. So Devin, hey old buddy, here's your 76 doll hairs. But Sam earned more than that. How much money total was earned? 220. So I could take that money of Devin, plug it in, so I have x plus 76 equals 220.
But I could just minus.
So, yep. So 220 minus 76. You guys have the calculators.
144.
144? Hey, look at old Sam. He came out with 144 bucks, and his buddy showed up with $76. What? It might be because we have portrayed Sam to be a larger person than Devin. Maybe, I don't know. Hang on. I forgot something here. And you know what? I made an error. Did anybody see the error I made? Because this worked out all really. What's that? I forgot something. I forgot something really, really important. What do you think? No?
Multiply?
Multiplication has something to do with it.
Yeah, it's like, what'd you do? When you put the parentheses and multiply them by
No.
distribution?
Nope. It has to do with the setup of the problem. Yeah, what do you got? No.
Oh, wait.
Yeah.
Which problem? Well, over here it says 3y minus 8 equals 220, and then u minus 8, but it showed it was 228 instead of 212.
I added 8 to get there.
You had 8.
Added 8. Anyone else see it?
You had to.
How the whole thing is set up with my work is correct. My initial setup has something really important. Yeah.
Are you supposed to multiply the 4 hours?
Yeah, baby. I forgot all about 4 hours and 6 hours. So this should have been 4x plus 6y equals 220. I'm so dull.
That's what I was like.
I'm sorry. So I need to erase this. I need to erase here because those were an error. And that. I'm so sorry. I didn't mean to make an error. Every now and then I might make something wrong. Okay.
Okay, everybody makes mistakes.
Well, thank you for understanding. All right, so we can't. So we're trying to figure out their hourly rate. So it's still set up as substitution, and I could still plug 2y minus 8 in for x. Agree? So I'm still going to use this top equation here. So I have 4. There was an x there, plus 6y equals 220. What am I going to plug in right there now? 2y minus 8. Distribute. So I get 8y minus 32 plus 6y
That's
equals...
what I said. I said distribution, and you said I wasn't right.
I'm so sorry. I made an error. I didn't mean to. All right, 4y and 6y add together give me 14y minus 32 equals 220. Add 32, so that gives me 252. Does somebody have a calculator?
I do.
What is 252 divided by 14?
13.
13?
I don't know.
Oh.
16.
16? Maybe? I don't know.
It's 18.
18? 18. Wow. 18?
That's
Devin's making some money.
He got 18 bucks.
18 bucks
an hour.
an hour,
No.
Oh.
right? So this cat made $18 per hour. And then his friend, Sammy, 2 times 18 is 36. 36 minus 8 is?
8.
8, 28.
Is that right? 36, 28?
26.
28.
28 per hour. Dude, are you kidding? Sam's making 28 bucks an hour? Devin's making 18? Man, righteous bucks. I'm so sorry, I didn't mean to make an error. And where I caught my error was I started looking at it going, wait a minute, this isn't going to make sense with our equations. So if we do this correctly, if I go, does somebody have the bigger graphing calculator? So you can double check my work.
It is.
No, you can do it. I'm going to tell you exactly what to put in. Ready? Okay, so we're going to go 4 times 28 plus 6 times 18, enter. Cool.
What? That's crazy.
I know I did it right that way. I couldn't do it right the other way.
It's okay.
And then if I do this for me too, please. You still have your calculator up. So 2 times 18 minus 8, enter. It worked. Got it. Good. Thank you. Huh. Woo! How you feeling? I want to know what jobs these 2 cats got, man. 28 bucks. Oh, yeah, baby. Can I move to the next problem? All right.
What cartoon of boy? Cartoon of cheeseburgers? Why don't you
Chester.
why don't you do actual cheeseburgers? Don't do cartoons. Veggie burger. It's so funny.
We got a plain hamburger picture.
Just type in hamburger.
Oh, there we go.
Not cartoon.
Oh, I feel better about myself with cartoons though.
But I want to look at regular hamburgers.
Yeah, but I don't want people to get like hungry and.
I'm already hungry. Presley,
What?
the Miss Thomas's like secretary, what's her name?
Jen?
Jen. We were looking up food all 4th period.
I
It was
really
so
love
funny.
Jen. She's the
I
best.
love her. She's so
That's my favorite. She's gonna retire soon. I'm so sad.
The whole time.
What am I supposed to do when she retires and I don't get an in-house? And then we just have to sit there and say,
Maybe you don't want to get in house anymore.
I honestly would
don't
love
have
to get
in-house
in-house with
week.
Jen. Thank God. she
I
is
just
mine.
went last week and Jen's so fun to do that.
Thank God I
She's
have Miss
great.
Thomas as my team.
Well, I do not want her to retire until I graduate. But gotta hold on to her for 4 more years.
All right. Cheeseburgers take 6 minutes to make, and hamburgers take 5 minutes to make. Not sure why slice of cheese adds an extra minute,
Because it has to melt.
but it does. Okay. Cheeseburgers sell for $5. Hamburgers sell for $4. That better be a good burger, because I go over to that McDonald's.
I know, right? It's nasty. It's not nasty.
It's so good.
It's so good for you too.
They
A
have good
certain.
Actually, take your McDonald's.
All right. So.
Do it.
So we have time here. How long does the cheeseburger take?
6 minutes.
6 minutes. And then how long does the hamburger take?
5 minutes.
5 minutes. How much does the cheeseburger cost?
$5.
$5. How much does a hamburger cost?
$4.
Okay. Okay, everyone agree with what we have so far?
Yeah.
Life is good? All right. A certain combination of cheeseburgers and hamburgers cost $44 and took a combined time of 54 minutes to make. Okay? All right, so we have to establish, we'll call cheeseburgers X, we'll call hamburgers Y. Is that okay? So, I know that 6 times X plus 5 times Y, the 6 and the 5 are as far as time goes. Do you agree?
Yeah.
So, how much time did the combination take to make? How much time did it take to make the combination of burgers? Whether it was 10 and 3 or
11 minutes.
a what? It was 11 minutes?
What?
Look at the problem. How long did it take?
54.
54 minutes.
Oh,
Took us 54 minutes.
my bad. I
To
was
make
at
this.
6 plus 5.
All right. And then we know that $5 for the cheeseburger and $4 for the hamburger, what if some combination cost us how much money? $44. Okay, so this one's talking about the amount of time, and this is talking about the amount of money. Okay, so we had a time portion and a money portion. All right, so let's see if we can figure this out. These two equations. Okay. Oh shoot. If I added them right now, I'd get 11x plus 9y equals 98.
I was just thinking we would have to eat.
Would add the equals?
Because then you could put it all into.
I can see that. What do you think?
Times multiply the top by 5 and then the bottom by 6.
Okay, so what are you trying to get rid of then?
Just x's.
Okay, so we have to. I think we have to multiply both equations by a number. So we have to pick either x or y.
By 2.
Let's see, would 2 work? That would give me 12 and 10, 10 and 8. Nope, 2 wouldn't work.
Oh!
So-
Negative 2 on the bottom for y.
That would give me
Negative 5.
See what?
Negative 5.
on the bottom
Yeah, for y.
for y, and then
20.
okay. So let's take care of that. Hang on. 25x minus 20y. I like it. Equals. Hey, what is negative 5 times 44?
Negative 5 times 44.
Yeah,
Let me check.
I think it's 220.
44 is negative 220.
Yes, I got it right. All right. So we're getting rid of the y's, I think, right? So what should I multiply that top equation by to have opposite y values?
4.
A 4. Yeah. So this was distributed here, here, and here to get that. This will go from here, here, and here. So keep those calculators out. Say I get 24x plus 20y equals, what's 4 times 54?
4 times 50.
216.
216? Okay. If I add these two equations together right now, what's going to go away?
Y.
The y. Okay, so that'll cancel that. That gives me negative x equals negative 4. So x is equal to
4.
4. Okay. So we got 4 of these. Do what I do? So how am I going to figure out my y component?
Plug it in.
Yeah, I need to plug that 4 into either of the x's. Doesn't matter. I might plug it in here or here. We'll just take the top equation. So I have 6x plus 5y equals 54. So 6 times 4 plus 5 times y equals 54. That's 24 plus 5y equals 54. Subtract 24. So that gets to 30. So y is equal to 6. So if I made 4 cheeseburgers and 6 hamburgers, according to our method, it would take us 54 minutes. It would cost $44. Wow. That's a long time to be cooking burgers. All right. All right, last problem. Problem number 5. Bless you. Hey, it's a swim team. A swim team. This is awesome. It's girls' swim season right now for high school, so that's awesome. A swimming team used vans and cars to transport swimmers to a swim meet. Okay? Each van had 7 swimmers. So there's 7 people here. Each car had 3. Okay? So I think we'll call the vans X, we'll call the cars Y. Still with me? Alright. I gotta hurry up on this one so we can make sure we're done. Alright. So 7x plus 3y. So 7 vans plus 3 cars would have given us a total of 66. Okay?
Yeah.
We're transported using a total of 10 vehicles. Oh, we used 10 vehicles. What kind of vehicles we had? We had vans and cars. So we had X plus Y, and we had 10 of them. Okay? How is that set up?
You put it in.
The takeaways one.
Yep. So, we're out here at 10:06, yes?
Yeah.
Yeah.
All right. So, I want you to finish that problem. Bring me an answer tomorrow. And then also try page 164, 165. That was when you tried already, huh? So tomorrow when we do the lawnmower problem, you're like, I got it. Right? That's right. Good job today, guys, girls. Have a great day.
Again.